All right, so if we're looking at a normal distribution, this is a review from back in Unit 2 or Unit 3. So I need my standard normal distribution table. It's got all my probabilities on the inside and z-scores on the outside. So if I want to know the probability that z is less than 0.54, then the only thing I need to do is look up the z-score, 0.54, and I find 7054. That's the probability that I would find a value less than 0.54. Now, if I sketch that graph, here's 0, here's 0.54 right about here. So that's about 70% of my graph. Now, when the question is probability that z is greater than negative 1.12, I'm still going to use the same process of going onto my normal distribution table. I'm still going to look up the z-score, negative 1.12. And I'm going to get 13.14 right here from the table. But if I sketch that, I should quickly notice something. Here's 0. Here's negative 1.12. If I want to know the probability that it's greater than negative 1.12, I notice that probability is not 13%. So what that table tells me is this percent over here, which is less than negative 1.12. So what I need to do is I need to take that value, subtract from 1. I get 0.8686. Now that looks a whole lot more like 86% than it does 13%. Right? So that's the 86%. Now, I tell you guys, if you look at the graph of these things, it always helps. 1, 2, 3 is here. So 3.89 is over here. Well, when you go look up 3.89 on your table, you find out that it's not on your table anywhere. Only go to 3.4. Well, what's the probability that it would be more than 3.89? In this case, it's just 0. Won't happen. And if that question had been less than 3.89, then it would have been 100%, right? Less than that is all the graph. Greater than that is none of the graph. All right, so we had a less than, a greater than, and now we've got a between 0.49 and 1.82. Now, when I look at this guy, I always remember this first one that we started with. If I tell you that that's 90%, and this is 30%, then between those two, it's got to be 60% by subtraction. So that's all we're going to do in this problem, but we can't just subtract the z-scores. We need the percents. So I'm going to have to go look up the z-score. 0.49 is 6879. 1.82 is 9656. And then just subtract those two values. All right, now when I subtract those two values, I get 2777. That's the probability that it would be between those two values. All right, now looking down here at the bottom, we've got 3-year-old females having approximately normally distributed heights with a mean of 94.5, standard deviation of 4. So when I look at that, first question says, what proportion of 3-year-old females are taller than 100 centimeters. Well, if I graph that over here, right, 0 is the average. I need to know where 100 centimeters falls on this graph. So in order to find that, I'm going to find the z-score. I take the value minus the mean divided by standard deviation. So if we look back at the formula for the z-score, it's x minus the mean divided by the standard deviation. So when I divide that, I get 1.38. Now, I'm going to go look in the table. I'm going to look up 1.38. Find 9162. But when I graph 1.38 and I look at the question, it says, what's the probability that it would be taller than? That does not look like 91%. It's because it's not. This table only tells me less than. So in order to get the greater than, 1 minus 9162, I get 0838. And that is the probability that a 3-year-old female would be taller than 100 centimeters. And then we look at what proportion of 3-year-old females are between 90 and 95. Well, that's sort of like this question up here that we just did between these two values. So the first thing I'm going to need to do is find the z-score for each of them. 90 minus 94.5 over 4, which is negative 1.13. And then I'm going to look at the other z-score, 95 minus 94.5, which is very close to the mean. Turns out it's 0.13. I'm going to not subtract these two guys. I'm going to look up the percentages, which are all right, 1314 and 0.13. Oh, that last one was 1292. I knew something was wrong. And then look up 0.13. Which is 5517. Subtract those two guys. And I'm going to get 0.4225. All right, now last question says 80% of 3-year-old females are at least how tall? So that means 80% of them are more than how tall? So that means over here is 80%. So what value, what z-score corresponds to 80%? Well, if I look up 80%, no. If I look up 80%, I get 0.84, but that's way over here. So what I really want is the lowest 20%. So when I look up the lowest 20%, here's 6, 14, 9.